Hi, this is David Berglund with the AI Impact Series, now here with episode 4. Today we are diving deep into artificial intelligence risks and governance. Some of you may have a reaction to those terms, thinking governance simply means the team at a company who says no, policing and preventing AI. Instead, I like to think of it as how you can build the right checks and balances while still making rapid progress. More speed, less headaches down the road. There's clearly a lot of excitement around AI recently, and for good reason. We're seeing new things become possible that were science fiction just a few years ago. But you may be surprised that most organizations are still relatively early in their journey to adopt AI. According to a recent IBM study, just 35% of global companies have AI in production, and an additional 42% are exploring it. What's the challenge? Well, according to a Gartner study, the top barriers to AI implementation are data access, data volume, and measuring the value of AI. So naturally, those are the key elements you'll want to solve for when building out an AI strategy or practice. Data also happens to be a key facet of solid AI governance, and this becomes even clearer when we look at the machine learning lifecycle. Here you can see there are 3 key stages in machine learning solutions: learning, inference, and feedback. To illustrate how it works, let's use the example of training a supervised model how to predict the value of a house, like we did in episode 3. First, we feed our model with historical data, including various features of houses, such as their location, size, number of rooms, and most importantly, their selling price. Our model tries to understand the patterns and relationships between these features and the price. It's like creating a mental map, or more precisely, a mathematical function that links the features to the house price. And this is the process of learning from data. Once the model is trained, we move on to the inference stage. Now, let's say our prediction is going to be used in an application like Zillow, the home buying marketplace. Imagine there's a new house that just popped up on the market. Zillow would query the model, sharing the features it knows about the house, and the model will respond with the expected value. But of course, the model may not always be right. So how does it improve? Well, that's where feedback comes into play. Once the actual price of a house is known, we can compare the model's prediction to the actual price. This comparison forms a feedback loop that helps the model learn from its errors and adjust its mathematical function. Over time, this process of training, inference, and feedback enables the model to get better and better at predicting house prices. Now let's overlay some of the key AI risks across the lifecycle. While the chart is simple, AI is a complex process, and each of these stages carries its own set of risks. One major risk with AI and machine learning algorithms is using biased data when modeling. If the data used to train the model is biased or unrepresentative, the model will generate biased outcomes. Even with the best of intentions, many companies are realizing that their historic data is likely skewed or biased because the data is a reflection of existing human biases. A key focus should be to curate an expansive, balanced, and diverse dataset to avoid bias and optimize performance. Next, we have the idea of model accuracy and overfitting. Companies use machine learning models to make practical business decisions, and more accurate model outcomes result in better decisions. The cost of errors can be huge, but optimizing model accuracy mitigates that cost. Similarly, we want to ensure our model doesn't perform well only with the historic training data. The better a model can generalize to unseen data, the better predictions and insights it can produce, which in turn delivers more business value. The third risk is model transparency. AI models like deep neural networks are often described as black boxes because it can be hard or nearly impossible to understand and explain how they make a decision. This lack of transparency can pose issues for regulatory compliance, third-party oversight, and user trust. And for certain use cases like credit decisions in banking, explainability isn't just something you should want, but it's mandated by law. So consider the trade-offs of models that are more explainable, like regressions, and if the reduced complexity is justifiable given its performance. The history of AI is dotted with examples of machine learning that went awry, from biased facial recognition software to flawed algorithms in legal systems. These incidents highlight the potential harm of unchecked AI. A good first step companies should take to reduce ethical challenges is promoting diversity in AI. The teams developing AI systems should reflect the diversity of the people those systems will affect. A diverse team can help identify potential bias in AI systems and work towards mitigating them. Remember, it's never too early to adopt a strong AI ethics framework, encompassing principles like fairness, accountability, transparency, and respect for user privacy. Just like with any other technology, AI systems aren't immune to security threats, making their protection an absolute necessity. We've seen plenty of instances where the lack of adequate security measures led to damaging breaches. When AI systems aren't properly secured, they can be exploited and misused with potentially devastating results. Similarly, with generative AI gaining momentum at many companies, you should keep in mind that just because an AI wrote the code doesn't mean it's impervious to security flaws. While an engineer may be 2 times faster with an AI copilot, if the code isn't secure, you won't want to push that code to production. So instill a culture of security by design. Make sure that every team member, from engineers to executives, understands the importance of security and follows best practices. Finally, we have the idea of model drift, a term used to describe when the predictions of a model start to become less accurate over time. This can happen when the underlying data changes or evolves. For instance, during the COVID-19 lockdown, buying behavior, travel trends, and even media consumption changed. Models that were optimized pre-COVID may not perform as well as they once did. Model drift can be a risk for organizations because it can lead to inaccurate predictions, which can in turn lead to financial losses, regulatory fines, or other problems. So how can companies manage these risks? The key lies in constant monitoring and adaptation. Put in place a plan for regular model retraining. With new data continuously coming in, it's important that machine learning models are frequently retrained to stay relevant and effective. You can also consider using dynamic models that are able to adapt to changes in the data. This will help organizations maintain the accuracy of their models even as the underlying data changes. Just keep in mind, if you're continuing to incorporate those learnings, there's a risk that the model could veer in a direction you never expected. And this is where continuous monitoring of model performance comes in. Companies should establish automated systems to track model performance and set up alerts to notify the relevant teams when the metrics of the model start to deviate from expectations. Clearly, a successful AI strategy and governance plan isn't just about the algorithms. It's a holistic approach encompassing data, models, people, and business value. As you start to deploy AI at your organization, you now have a better idea how to spot and minimize risks. Best yet, many of the best practices that we just ran through will actually help accelerate your organization's ability to deploy trustworthy and high-impact value with AI at scale.